Welcome children to our last class of algebraic expression. Today we'll learn how to find the general term, the rules to find the general term of number patterns. Okay. Now let's take a simple example pattern of an even number. Now as you know, like 2, 4, 6 that are even numbers. Now how will you find out if they tell you what will be the 10th term or the 20th term or the 100th term or 900th term, 910th term? So how will you find out? If you know the general rule, then you can find out any term, the value of any term. Now for this, let's start with the simple one. Now 2, 4, 6. How are you obtaining this? See here, you're getting 2 into 1, 2 into 2, 2 into 3. You can write it down, 2 into 4, isn't it? And then, so fourth term is what? 2 into 4. Third term is 2 into 3. So the nth term will be 2 into n. Now see whether it is correct or not, we can put the values and find out. So if you write for n is equal to 1, the first term is n is equal to 1, isn't it? So you get 2. So the first term is 2. The second term, that means n is equal to 2, the second term. So we put here 2, we get 4, isn't it? So this is how you find the general rule. Now for odd numbers, now these are all odd numbers, but you can also find the value of any term. Now suppose this is the first term is 1, second term is 3, third term is 5. So if you observe, now these are actually with practice you will learn, but now just let me tell you that 2 minus 1 is this. 4 minus 1 is 3, 6 minus 1 is 5. That means what? The first term is even number minus 1. This even number minus 1. So this pattern we know is 2n. So 2n minus 1 will give you the nth term. Isn't it? Odd numbers are also 2n plus 1 because 2n is always even. So even if you add 1, you'll get odd number only. But here why I'm taking 2n minus 1, because in this pattern you just check. If I put n is equal to 1, that means the first term is 1, isn't it? First term and first term is 1, we get here 2 ones are 2, minus 1, 1. So we are getting this. When the second term means 2 into 2 minus 1, that is 3, 4 minus 1. Now for 100 term, what will be the value? You put n is equal to 100 and you get accordingly. Is it clear? Now for the natural number. Now we are doing natural number success. A natural number are what? Counting numbers 1, 2, 3, 4 and all are called natural numbers. So what do you have? So if n is a natural number, what is the successor? Successor we always add 1, so we can say n plus 1. Now for any term, if I say when n, what is the successor of 15? So n is 15, successor will be 15 plus 1, 16. What is the successor of 1700? So that means n is 1700 and you add 1 to it, isn't it? So when you know this pattern, you can find the value of any term. Now these are the simple ones. Now pattern for square numbers also we have been doing. So with 1 dot, it's a special square, we say 1 into 1. Now here 4 dots, all equal distance from each other. And when we join the boundary, we get a square. So they are called square numbers, and 2 into 2 gives you 4, isn't it? That is how you find the square numbers. Next is 3 into 3. That's a square number. And you put 3 dots here, 3 here, 3 here, total it is 9 dots. And when you join the boundary, you get a square. So it's a square number. Similarly, you get these you have done in the previous classes. So I'm not going into details. So 4 into 4, total 16 dots, isn't it? So this is another square number. When you join the boundary, you get a square number. So what do you observe? How you are getting 1? 1 into 1, 4 is 2 into 2, isn't it? 9 is 3 into 3. Now you see here, first term is 1 into 1. Now this is the second square. Second square, how many dots? 2 into 2. Third square, how many dots? 3 into 3. So the nth square will be what? N into n. Now suppose you want, now I've done here fifth square. So you see here fifth square will be what? 5 into 5, 25, and it's correct also, isn't it? So for 18th square, it will be 18 into 18, so you can find out like that, the values. Now here is another pattern. Let us consider the pattern below with matchsticks. Now here's the square, 4 matchsticks. Here there are 2 squares. This is common. So we have 7 matchsticks. So accordingly, can you see the number of matchsticks when you count? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So what will be the nth term? Now all these will need a bit practice. Now here I form a grid. You can form a grid in the previous ones also. Now here the squares, the first square, the second square, and so on, I'll write. And here the number of matchsticks required, I'll write. So what I'll do, when the square is 4, when the square is 1 square, you have the number of matchsticks you have is 4. Now when there are 2 squares here, these are the number of squares I'm writing, okay? When there are 2 squares, how many matchsticks you have? 7. When there are 3 squares, how many matchsticks I have? 10. So that is what I'm writing, okay? So when there are n number of squares, how many matchsticks we will need? Now this you have to think, okay? Now if you observe, it will need a bit of practice. I'm repeatedly telling you. So 3 into 1 plus 1 is 4. 3 into 2 is 6 plus 1 is 7. 3 into 3 plus 1 is 10. So third term is what? 3 into 3. Fourth term is what? 3 into 4. So nth term will be what? 3 into n. And then finally we are adding 1. Isn't it? We are multiplying these by 3 and then adding 1. So nth term will be what? 3n plus 1. So when n is equal to 12, that means number of squares are 12, then how many matchsticks you will need? This is how you do it. 37. Now just to confirm, you can find out the 6th term or the 10th term, and then you have matchsticks at home. You form it. So for maybe 6th and 8th or 9th term, you find it from this grid. Then you make the squares with the matchsticks, click a photograph, and you can send it to me, or you paste it in your classwork copy that you have practically done it using the matchsticks and using the formula. Is it clear, all of you? And see if it matches or not. Your concept will also become more clear. Now here is another pattern. For 1 square, you have 4 matchsticks. For 2 squares, you have here 8 matchsticks, isn't it? For 3, you have 12. So finally, for n squares, how many you will get? So this is how I'm checking, see. For the first square, it's 4 into 1, 4 into 2, 43. So for n squares, it is 4 into n, isn't it? Now here I'm giving an activity, which you can practically do it. And it would be nice if you could have some matchsticks, okay? And you click photographs also, because don't stick it in your copy. Usually we do as a separate practical, but now since you are at home, you can just make it on your bed or your study table, click photographs, count the number of matchsticks, you can color the matchsticks, and see how you can present it nicely, and you understand also properly. Now here there's a trapezium. You know what a trapezium? One pair of parallel sides. Now here there's 1 matchstick, 2, 3, 4, 5 matchsticks. Okay, because this part is longer, isn't it? 5 matchsticks. So the matchsticks are placed in this order. I hope you'll be able to place the matchsticks, and then you count and just check here how many. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this way you get, for number of trapezium, when there's a 1 trapezium, you have 5 matchsticks. When there are 2 trapezium, you have 9 matchsticks, and so on. Now, what is the general formula? If you observe, at least 3 numbers you have to, 3 grids you have to fill up. 3 numbers you have to find the values, okay? So that you are able to understand better. Now, when you get 3 here, 3 numbers, now see, how do you get the rule? It will, as I told you, it will need a lot of practice. So 4 into 1 plus 1. The second one is what? 4 into 2 plus 1. 4 into 3 plus 1. That means 4 into this term plus 1. So 4n plus 1. And then you have to prove, or you have to check whether you are correct or not. Then only you can say 4n plus 1 is the general term for the finding out the number of matchsticks when n is the number of trapeziums. So you find the value for 5, find the value for 8, then you can color the matchsticks, arrange it, okay? And you can click photographs and you can make a nice project so that when school reopens, we can have a combination of what? Practically, you have observed it, forming the grid, mathematics combined, algebra, and finding the nth term, isn't it? So you can do it. But till then, we have come to the end. Okay, I hope you have understood. And still, if there's any doubt, you can always get back to me. Till then, be safe. Bye-bye.